Hello, today it's time for another episode
komputerowego ciemnej energii. Znajdujemy się w tym oto
We are here,
model komputerowy,
a computer model of dark energy. Numerical model of dark energy has already been presented, episode 3 and episode 7 for entire galaxy.
gdzie dotyczyła sprawa całej galaktyki. Zgadza
This
się,
has already been shown. This episode is
ten
optional.
jest opcjonalny. A dlaczego tak jest?
I have already shown the dark energy model in program Mathcad 15. This episode is optional. Now I will show you the same model, but in a different program.
W innym programie. Dzisiaj będzie to program
This is Mathcad Prime 10. This is the latest version of the program
Nie
Mathcad.
jest kompatybilny.
This version is not compatible with older version of the program. Files are not compatible.
Różnią się od siebie, nie są do siebie kompatybilne.
However, the
ale
programming
sam
style
program,
is similar,
sama
with few
struktura
differences.
obliczeń wygląda bardzo podobnie.
You will find out in a
Przekonacie
moment.
za chwilę. To jest
This
opcjonalny
episode is
odcinek, jak
optional.
powiedziałem,
If you prefer another program,
tylko
skip
dla
this episode.
zainteresowanych osób.
There will
właśnie
be different
Mathcadem
episodes
Prime
for
wersji
other
10.
programming
Jeżeli chcecie w tym
languages.
programie
If you choose
programować,
Mathcad Prime
to
10,
zapraszam.
keep watching.
Jeżeli wolicie wybrać
I invite you to
inny
watch.
z tej listy programów, to uruchomcie odpowiedni odcinek z danym programem, tak? A ten pomińcie. Tutaj
Here
się
are the
linki
online links to the
z wszystkimi
files
skryptami,
for all
z
model
wszystkimi
versions.
modelami wszystkich wersji
One link
dla
is
wszystkich
enough to
programów
download the file,
matematycznych.
zip archive.
Jeden link wystarczy, aby pobrać plik archiwum zipa i
It must
rozpakować
be
to
unpacked
sobie na
on your
dysku
computer
twardym.
hard
Będą
drive.
dostępne katalogi
After
z odpowiednimi
unpacking the file, the
programami,
program
a w środku
directories
tych
will be
katalogów
available.
odpowiednie pliki
The appropriate
z modułami.
models are
Także
contained in the
jeden
folders.
link wystarczy.
One
Ja
link
tutaj
is enough.
przygotowałem kilka,
I prepared
tak na
several
wszelki wypadek,
copies.
gdyby któryś serwis
If one
przestał
service
działać,
stops
to jest
working,
drugi link,
you should
czy
choose
trzeci.
another one.
Wystarczy sobie skopiować i pobrać plik. A zatem
Version for Mathcad Prime 10.
Prime.
On the left, select the appropriate folder, Mathcad Prime 10. On the right side, you needed to run the file with the dark energy model for the selected object. Let this be the third file, model for Earth, dark energy 03. The program has been started.
Zwróćcie uwagę tutaj u góry. Jest
Here
nazwa,
at the top
tak, Mathcad
is the file name,
Dark
dark energy 03 Earth.
Jest uruchomiony, Ziemia.
We start with the basic variables. It's the basic parameters of this astronomical object, planets or the Sun.
Potrzebujemy
We need the light speed,
stałą grawitację,
the gravitational constant,
masę
the
obiektu
mass of the
wokół
object.
Ziemi, promień
Here
Ziemi,
is the radius of the Earth, the acceleration of gravity of the surface of the Earth,
Ziemi,
volume.
objętość,
This is the formula for the volume of a sphere.
wzór na objętość
4/3 pi times r to the third power. We use the standard volume equation. Average density of the planet. This is the ratio of a planet's mass to the planet's volume. Rho is here. You must declare the number of layers for the object. Layers. Selected layer parameters that will be calculated. You can set any number of layers. For example, it can be 100 layers, 1,000 layers, a million layers. The number doesn't matter. I set 1,000 layers. This number can be changed. You can set it yourself. The radius increment is directly related to the number of layers. The radius increment, delta r, is the ratio of the planet's radius to the number of layers. He is about 6,000 meters, a little more than 6,000 meters. The single layer of the planet is about 6 kilometers thick. Variables are not complicated. These are the basic variables, the basic physical parameters. The listed parameters are quite enough to calculate the gravitational energy of an object. The equations to calculate gravitational energy are already known. This was shown in the previous episode. What's next? We are moving on. Remember what you need to calculate first. These are the basic physical parameters for a sphere as a function of radius. Below is the construction for calculating these parameters. On the left side is the variable declaration. Down here, these are the same variables. Here's how to extract variables from a program. This is the programming loop, the place where all calculations are performed. Please note that the declared variables correspond to the physical parameters. The basic physical parameters, what were shown in the previous episode. The first one is the radius. Here at the bottom, how to determine the radius of each solid. Surface area, 4 times pi times r squared, surface of a sphere. Volume, 4 thirds pi times r to the third power. Mass, mass is average density times volume. Gravitational acceleration on the surface of a sphere. Here is the equation. All the equations shown before are placed here. They operate in a loop and are calculated cyclically. Here is the declaration of the matrix size. The first step is the size declaration. All elements are set to 0 value. Nmax is the number of layers and it's set to 1000. The size of the matrix is 1000 therefore.
Rozmiar konkretnej zmiennej będzie równy 1000, no i wypełniane jest to zerami. Zwróćcie uwagę, tutaj
I deleted this loop for a moment. I temporarily put 1 to show the constructions of the declaration. All one-dimensional matrices have 1000 rows. Empty rows with 0 value. This is called a zero data vector.
Wektor danych, wektor zmiennych, wektor zer.
We are restoring the previous form. From the first element to the last, Nmax. Calculations will perform sequentially. First is R calculated. This is the radius of sphere number n. N times delta R. Delta R, its radius increment and was calculated earlier. Value about 6 kilometers. Surface area 4 times pi times r squared. Volume, another variable, 4 thirds pi times r to the third power. Mass is density times volume. Gravitational acceleration on the surface of sphere. The program should not lose calculation in the next step. The program should not forget variables and override values. Therefore, the program saves all variables under a different name. A new name for the radius here. For the row n, the value of the variable r was rewritten. Similarly, for the surface area. For the row n, the value of the variable s was rewritten. Similarly, for volume. Similarly for mass. Similarly for the gravitational acceleration. For row n, the value of variable a was rewritten, here calculated. The calculated values for all variables are shown on the right. Numerical model, computer model. The parameters of the primitives or spheres have been calculated. These parameters allow for further construction of the model. Dark energy model to calculate its value.
Dalsza konstrukcja
What's next?
umożliwiająca obliczenie ciemnej energii. No to popatrzmy dalej. No a dalej mamy obliczoną
Calculations for layers. We will calculate the volume of layers and the mass of layers.
Masę dla tej właśnie warstwy, dla tego shella.
Variables are declared here. V shell, volume of layer, M shell, mass of layer. Here, the variables are derived. As before, declaration of the matrix size. Nmax is 1000 elements. Programming loop with calculations. The volume of a single layer is calculated here. It is the volume of a sphere n minus the volume of the sphere n minus 1, a sphere one size smaller than the previous one. The difference between these values is the volume of the layer. We performed similar calculation to determine the layer mass. The mass of a single layer is the mass of the ball n minus the mass of the ball n minus 1. The ball one size smaller than the previous one. The difference between two values is the mass of the layer. We remember how it was explained. A ball of size n minus a ball one size smaller, n minus 1. For mass, it's similar. These equations are applied right here, in this loop. Numerical calculations are shown on the right. It is worth noting that these equations are in symbolic forms. This is the form of equations we write in notebooks. The natural form of physical equations. Mathcad allows to use symbolic equations. Just one look is enough. You immediately know what is written. Parameters for the layers have been calculated. The next is force. The gravitational force for the layers. Here, the gravitational force is calculated from the bottom to the top, from the object's core to the surface. This was explained in the previous episode. The gravitational acceleration at the object's surface is marked in blue. On the surface of internal ball, the gravitational force is the mass of the layer multiplied by the gravitational acceleration. Mass of layer calculated for larger sphere minus smaller sphere. Difference of both masses. Force of gravity consists of two variables. First is the mass of the layer. Second variable is the gravitational acceleration, internal sphere. This is the gravitational force for sequent layers. It is worth noting that all the parameters have already been calculated. Parameters necessary to determine the force of gravity. Here, under the loop, the variable for mass. It is similar for the acceleration of gravity. However, the acceleration must be chosen for a sphere one size smaller, n minus 1. This is very important. The force of gravity is calculated by simply multiplying both variables. Calculations. This is the gravitational force for the sequent layers, except the first layer, of course. The first position is empty. The calculations are performed from the center of the object to the surface of the object. Here are the previous calculations, and here at the bottom are the next ones. Counting from the surface, we will add up the force values for sequent layers, because the values for the sequent layers should be added together. The current layer is summed with the previous layer, from the surface of an object to its center.
jest sumowana z jeszcze wcześniejszą środka.
Here is the realization.
Konstrukcję, gdzie
The loop starts from the value nmax minus 1 and run to the first element,
minus 1 aż do pierwszego, czyli
from the
od
surface
powierzchni
to the center.
do środka
Simple summation
obiektu.
operation.
To jest po prostu zwykłe sumowanie.
The gravitational force for layer n
Jest to
is
siła
the gravitational force of
tejże
that layer
n warstwy
n plus
dodać
the
siłę
gravitational
grawitacyjną
force
warstwy
of the
o
layer
jeden
one
więcej,
size larger.
ponieważ ta siła
n plus
grawitacyjna
1.
dla warstwy
A
o
layer
jeden
one size
większej
larger already contains
zawiera
all
już w
the
sobie
previous
wszystkie
layers.
jakby poprzednie,
Layers we
wcześniejsze,
added earlier.
najwyższe warstwy zsumowane. Tak? I tak sumuje to wszystko i mamy rzeczywistą wartość siły na konkretnym
Here is
poziomie,
calculated
na
the
konkretnej
actual force value.
warstwy obiektu.
Values are recorded
I
in the
tutaj w
table.
tabelce są oczywiście wartości numeryczne podane.
We
Pamiętamy,
remember how it was explained.
jak to obliczyć, tak?
Now we know the gravitational force
Mamy
inside
siłę
an object.
obliczoną dla konkretnych warstw.
Now it's possible to calculate the internal gravity pressure value.
We wnętrzu obiektu właśnie dla konkretnej warstwy.
Gravity pressure of layer is the ratio of gravitational force to surface area.
Siły grawitacyjnej dla tej warstwy podzielonej na
The gravitational force between the selected layer and the surface of a sphere one size smaller, n-1. The sphere is located directly under this layer. This layer is located directly on the surface and pressed against that surface.
Podzielona na to pole powierzchni daje nam
Gravity pressure is
ciśnienie,
generated,
średnie
the
ciśnienie
average
dla
pressure
tej
for layers.
warstwy.
Here under is similar constructions as before.
Podobna konstrukcja jak wcześniej.
Declaration of pressure
Ciśnienie
variable.
tutaj musi również być na
The
wyjściu
output has a
zadeklarowane,
similar
wciśnięte.
construction.
Jest tylko jedna zmienna press, czyli ciśnienie.
Declaration of the matrix size.
Macie
Nmax value is 1000. All elements are empty and have a value of 0. The loop iterates from the surface Nmax to the second layer from the center.
wewnętrznej warstwy.
Surface area of the sphere one size smaller, n-1,
danego obiektu
the smaller one.
jest pole kuli n-1, tej mniejszej. Mamy
Here is the gravitational force for layer n.
NT, tak?
F
Stawiam
is
sobie
the
podniesienie
force symbol.
F, żeby było prościej. To
Below is the
zobaczyć. Mamy
calculated pressure.
obliczone
Here,
ciśnienie tutaj.
the pressure is the force divided by the surface area, surface of the sphere in this case.
Podstawiam pod nową zmienną.
New variable saves the calculated result for current iteration. The first layer could not be calculated. Here, the variable press 1 takes the value of the variable press 2. This problem was solved in easy way. There will be a small imprecision of the result. It is really small. This center layer, or rather, the central ball, core, cannot be calculated in any other way. That is why I said the value of the layer one size larger, value of second layer counting from the center. There are no significant difference between these layers. For a large number of layers, the radius increment delta R will decrease. Gravitational pressure has been calculated. Gravitational energy is coming close. On the right, energy is pressure times volume. All the necessary parameters were calculated earlier, pressure and volume for the layers. Now, we need to calculate the gravitational energy for these layers, shown here.
Jest to ciśnienie tej warstwy razy objętość tejże warstwy.
The gravitational energy for all layers will be calculated. The sum of the layer values gives the total result. Gravitational energy for object.
Daje całkowitą energię grawitacyjną.
Gravitational energy is equal of dark energy, but has a minus sign. Here under similar constructions as before for gravitational energy from the surface and max to the center of the object.
Max, czyli od powierzchni idziemy do środka, do centrum obiektu.
The volume variable takes the appropriate value from the table V shell.
Tymi warstwami, z objętościami tych warstw.
The pressure variable takes the appropriate value from the table press. Energy is pressure times volume.
Jest to ciśnienie razy objętość danej warstwy. No i mamy
Variable a graph saves the result.
Energia grawitacyjna dla konkretnej warstwy. Jest to właśnie podstawiane tutaj.
Table contains values for all layers.
Dla kolejnych warstw.
Notice, here it's the sum of all layers, from the first layer to the last layer, n max. Summation for 1000 layers. All the elements are added together for total value, the value of gravitational energy.
I mamy całkowity wynik energii grawitacyjnej, tutaj.
Below is dark energy.
Ciemna energia,
gravitational energy with a minus sign. Exactly the same value, but with a minus sign. Below is equation for mass equivalent for gravitational energy. I calculated for curiosity. We remember the most famous formula in the world. After rearranging the equation, the mass is determined, rather the mass equivalent. What mass value corresponds to this dark energy? That mass is being absorbed by the object at any moment, in 1 second.
Czyli niejako taki ekwiwalent masy dla tak obliczonej ciemnej energii jest zużywany w każdej sekundzie.
Below is the mass of the planet. It is declared at the beginning of the file. Input data. In this case, it is the mass of the Earth. The variable prots1 is 1% of the mass, 1% of Earth's mass.
To jest właśnie 1% masy planety.
The last variable is the percentage coefficient. Is the percentage of the dark mass to the mass of the object. For Earth, of course. Yes, how much of the Earth's mass is absorbed in the form of dark energy or dark mass. Percentage coefficient help us better understand this process. All results are presented in numerical form and we can browse them. But why make life so difficult? It is better to put the numerical data on a graph. Just take a look at the chart.
Liczbowe, dane numeryczne zobaczyć na wykresie. Wrzucamy to wszystko zatem na wykresy i zobaczmy, jak to wygląda.
First graph, gravitational force as a function of radius. This is logarithmic graph. The y-axis is logarithmic. The x-axis, radius, is standard.
To jest normalna, tak, zwyczajnie pokazane.
Below is the graph of gravitational energy, the most significant. The y-axis is logarithmic, the x-axis, radius, is standard.
W formie logarytmicznej, natomiast oś x jest zwyczajna, tak.
A graph of gravitational pressure. A graph of the surface of layers. A graph of the volume of layers.
Czyli dla tych objętości, dla tych warstw objętości, tak? Tutaj.
A graph of the mass of layers.
Mas tych warstw, tak?
Calculations and graphs for Earth. The same scheme can be used for any object. for any planet or sun or star or moon, even for a black hole. It can be calculated. We don't know what is inside a black hole, of course. If we know the mass of the black hole, volume, surface, and all necessary parameters, then we can try. There is an assumption that the density distributions should be constant inside the black hole. We don't know if this is true. If yes, then the calculations should be correct even for a black hole. I made example file for a black hole. I'll show you the results in a moment. I have prepared many other files for different astronomical objects. Sun. Here are the parameters of the Sun. Here are the results of the calculations. Mercury. Here are the parameters, calculation results. Venus. Here are the parameters, calculation results. Calculation for Earth have already been shown. Next is the Mars.
I tutaj mamy wyniki dla Marsa.
Next is Jupiter.
No i wyniki.
Saturn. Uranium. Neptune. Let's look at the results for the black hole. Just for curiosity. Result for the object Sagittarius A. This black hole is located in the center of the Milky Way. Here are the parameters and the results. But remember, this calculation is conditionally correct. I created this file because it's possible. Nobody knows what is inside the black hole. What is the structure of density there? The truth is the interior structure is not very important. Surface area, volume, radius, and mass are important. Calculations should be correct if density distribution inside the object is constant. If not, then the calculations will not be correct.
Natomiast jeżeli ten rozkład nie jest jednakowy dla wnętrza czarnej dziury, no to te obliczenia nie będą poprawne, będą dalekie od poprawności.
So, let's check it out. We won't lose anything. What is the result for the black hole?
Jak to by było dla czarnej dziury? Dlatego właśnie ten plik też jeszcze powstał.
I haven't simulated the moons, but that's a possibility. We can do calculations for the moons, for all the moons. I did not run simulation for Pluto because it is not allowed. The Astronomical Union has ruled out Pluto. Any discussion on this topic is strictly forbidden. I am joking, of course. Pluto can also be simulated. This is how we calculated the dark energy for an object, for many astronomical objects. Dark energy is flowing in. It's hard to calculate dark energy directly. The indirect method is much easier. You can calculate the gravitational energy inside the object. Gravitational energy is the equivalent of dark energy. What is inside is the equivalent of what is outside. It's much easier this way. That's exactly the simple method I was talking about. We have solution for dark energy, and that is the most important thing.
Na
Bye.
razie, cześć!